In this presentation, we are going to look at a worked example of the binomial probability distribution, and we're going to use statistical tables. So, suppose 40% of employees in a large company are believed to be in favor of unionization. A poll of 10 employees from this company was taken, and we can consider this poll a binomial experiment with n equals 10, n is the number of independent trials, and p, the probability of a success, is 0.40. The first question is, what is the probability that 4 or more employees favor unionization? 4 out of the 10, 4 or more out of the 10 polled. What we have to do here is we have to go to the statistical tables. And what we're going to do here is first off go to the binomial cumulative binomial probability tables. Now just check in your course if when you're using tables, are they cumulative binomial probability tables, and are they left-tailed or right-tailed, so to speak. These are the Murdoch-Barnes tables, but some other tables might work slightly differently. So first off, what we have to do is go to where n is equal to 10. So we have n equal to 10. So this segment down here looks promising, but none of the probabilities here match 40%. So what we have to do is basically go to the just keep looking through the tables. So n equals 100, no good to us. So we have n equal to 10 here, and over here, where the mouse is, we have probability of 0.40. So this sort of segment down here, literally this little chunk of the statistical tables, is what we're going to use. Now what we're looking at here is, for example, r is equal to 2. That means the probability of 2 or more employees out of 10 of the 10, 2 or more in favor of unionization. The probability of that is 95.36. So actually what we're asked though, we're asked for 4 or more. So the probability of x greater than or equal to 4 is, go to, just for this particular segment, just ignore everything else, go to where r is equal to 4, and we find the answer to be 0.6177. So that's straightforward enough. So that's the answer to the first question. So let's go back to there we go. So that's the answer there. The probability of x being greater than or equal to 4 is 0.6177. So the next question is, what is the probability that less than 2 employees favor unionization? Well, I'm going to look at the answer to that first. Well, this is where we would employ the complement rule. Now, x less than 2, that is equivalent to saying 0 or 1. And that is the complement of x greater than or equal to 2. Remember, this is a discrete probability distribution. So the complement of x less than 2 is x greater than or equal to 2. And what we have to do here, so I've actually written down the answer here. I've actually just mentioned it previously. 1 minus the probability of x greater than or equal to 2. So it's 1 minus 0.9536. Just working that out, use the complement rule for discrete probability distributions. Our answer will be 0.0464. Now I'm going to go back to the probability distribution tables again, and just let's be absolutely crystal clear about what I've done here. So I've gone to where r is equal to 2, row 2, and I just went across here and I found it to be 0.9536, and then subtract from 1. So that's that question. So I'm going to move on to the next one now. What is the probability of exactly 5 employees? Now just be careful about the wording here. Exactly 5 employees. Not 5 or more employees. 5 employees exactly. Now just to be clear, the tables works on the basis of some value or more than that. So how do we find out what x is equal to 5? How do we find that value out? Well, we can find out the value of 5 or more and then subtract the probability of 6 or more. So 5 or more means 5, 6, 7, 8 and so on. What we do here is subtract the probability of 6 or more, so that we're left with only 5. Now I have the two values here. 0.3669 and 0.1662. Let's just go to the tables just to sort of double check that we can see them there. It's that one there, 0.3669 and 0.1662, just over here. So that's the answer to that one. And finally, what is the mean and the variance of this distribution? Okay, well, that's not a question that is relevant to the tables. And the mean of the binomial mean is given by n times p. Here it's 10 times 0.4, which is in 4 employees. The binomial variance is np times 1 minus p, so that's 0.4. 10 times 0.4 times 0.6, and that would be 2.4 employees, which actually is sort of strange thing. It's actually 2.4 employees, but actually correctly it's 2.4 squared employees. That's a very hard thing to fathom. So that is actually how we would sort of specify the answer properly. Let's just go back to the tables and sort of see if there's any clues there. Oops, that would help us. Where am I? There we are. So, let's just say we wanted to forget, or we've forgotten what it was. So I'm just starting at the top here. What I want to do is just sort of scroll down through the statistical tables, and I just sort of draw your attention to these values here, and that it was, this would sort of indicate the, if you're familiar with that symbol there, mu equals np, and that symbol there, sigma, which is standard deviation, np times 1 minus p. So it's actually written into the tables. So, okay, that ends our presentation. Whoops.